Hi my friends on Hatariwater. This time we are going to do a quite good review and tutorial about how to impact assessment of water quality on ecosystems with neural networks in Python. So we will use neural networks to assess how the water quality parameters are related to the ecosystems in this area of study. This area of study is wetlands on the Peruvian Andes. So in fact, this is based on the data provided in this report done with Eduardo Llague and Mrs. Maldonado. Um, and the report is as well added on this will be added on the links of this tutorial and on this video. And this is a study done in 3 wetlands. I mean, there are places similar to these ones where they have taken samples of water quality as well. They have taken samples of water quality and some how say vegetation parameters, something like that. Okay, so what we have done is that we had, I mean, let's see if that I can show you how the data were. From the data of this report, hmm, let's see. Okay, from the data of this report that was at the bottom of the report, you will see these the parameters that were sampled were pH, conductivity, dissolved oxygen, total alkalinity, total hardness, nitrate, phosphorus, and so on. Okay, we shaped the data in order to be understandable by the code, and with the code and the neural networks we have done some graphs like this. So how is the variation of the, for example, this ecosystem variable like abundance of all vegetation with pH, as well as we have done with pH, we have done with nitrates, conductivity, and dissolved oxygen as well. So it's very interesting this exercise because you will see how these parameters are affecting, I mean, how the parameter on water quality have a real impact, or how is the trend, or if the parameter is relevant or this is not, and there are which will be the key issues in order to implement this for future studies. Okay, so let's start. Cool. First, in these lines of code, okay, I will restart and clear outputs just to because I want you to see from the beginning. So first we import the data. I am running what I do is just run the cells but from my keyboard, but I think that for you is maybe to run the cells from here. Here with this we import the data of chemistry and as well as the data of species. This data will be added as well to the link of this video. So okay, nothing has happened because we just put this data in our memory. Then we generate a data frame of chemistry with the same index as species because on the chemistry data we have more samples than on our species data, because the species data were taken just from a set of samples from the chemistry data. So what does it mean? That we have only 14 samples from maybe 30 points, something like that. Okay, so with this we just make it compatible our chemistry data with our species data. Okay, we run it. Cool. Then we have to normalize. This is very important because we want the computer to read our data. And if you have seen, this is the value of pH. pH is in the order of 6 to 8 something. and this is the value of conductivity, and this is the value of concentration. So if you see, the computer will be really hard to understand something that is on the order of the hundreds with something that is on the order of the units. So we have to normalize the data, and with this code we normalize the data, and we and then we multiply it by 100. Otherwise, because like there is the error of the neural network, and this error of the neural network will be in the order of the decimals. But if our number is in the order of the units, the error will be significant to the value of the number. So that's why we multiply by 100. Okay. Then we define a function of the neural networks. So we have this is a function that will run a neural network, because in this type we want to see which is the best method possible and which are the best parameters to solve the neural network, because it really depends on this. So we can set the the number of neurons, the learning rate, and the number of iterations. But IPython provides us a very interesting tool just to solve this problem. Um, and then we just have to define a function. So we define the function. So we just run it, and then we will create an interactive plot. So this interactive plot is actually an interactive view of this function where we can just play around with the data, and then we can see which is the best available and possible solution with of number of neurons, of number of iteration, of number of learning rate, and maybe of number of type of linear layers, or maybe non-linear layers. In this case, this is a non-linear layer. Okay, so we just run this, and then with the power of IPython, we have this is populating. And then we can see this is the observed abundance of vegetation, this is the calculated abundance of vegetation. What we want is that our points will be closest to this line, because it will mean that the observed is equal to the calculated, and then we can play around with this, like it's running, so we have to wait. Okay, and then maybe you want to see if more iterations will be add something to our schema. No, more iterations actually do not add nothing to the schema. Well, the number of species, because in this time our species is abundance of all vegetation. That's why we cannot move this. And let's say if more learning rate is available. Oh no, actually the neural network do not run with more learning rate, so we have to put less learning rate and maybe decrease the amount of neurons and wait, because it's okay. So you can play around and you can spend a quite good moment just playing around with this. Okay, maybe this was not the best one because no points are in this location. Okay, then you can play around, and then you can have a good idea which, and I have spent like some hours doing this, and then you can see which is the best parameters for your neural network, and as well that you can play around with these ones with the type of layers. Okay, we have used for this scikit neural network package, because for us is okay to is this one is is okay for our. We wanted to do it at the beginning with scikit-learn, but the multi-layer perceptron, that is a method that we have done, it was not available on it was just available on the development mode, so that's why we use this. Okay, so finally we keep the parameters. We will run with 1200 parameters. The learning rate will be this one with just 9,000 iterations. So we run it and then we wait. So this is our final neural network. Well, the neural network that is running with this, and then we see that we have a good fit. From the 14 points, we have just 3 that are located that have an error more than 5%, because this is the line of the 5%. Okay, now we can predict the ecosystem variable. So what we have done till here is just to see if our neural network actually represents, because it's really important, if the neural network represents the ecosystem variables by assessing the abundance of all vegetation. And in this one, what we will do is that we will have we generate some parameter for the prediction. So we run this, and then we run the neural network with the parameters obtained before, but this time we are not running, we don't have a function, but we run it like a organic, the neural network. So we run it, and then we wait because the neural network is running. If this point is black, is running. Okay, this is the, and then we generate some develop for the prediction, because this is actually the we want to assess, as you have seen here. Okay, sorry, as you have seen here, we want a distribution that covers that from this point to this point, and then in order to get this line, we have to generate this array of this axis. So that's why we do here. Maybe all this code will be on, and I say it again, all this code will be on the links on this video, so you will the code as well with the source data and as well with the publication, so you can play around with this, and then you can, like, maybe I recommend you to try to tweak it, to change some parameters at the beginning to see how this is going. Okay, so and then we will see which is the impact of pH on vegetation abundance. This code actually gives us, if we run it, so we run it, and then we run it, and then we see these interesting values. What does these values do? These values say, okay, if our pH is lower, so if we have more acid conditions, but this is not actually acid, if we have neutral conditions, we will have less abundance of all vegetation. If we have more pH, we will have more abundance of precipitation. So that is really cool. That's really interesting. And then we will run this of the conductivity as well. Like I say, if we have more conductivity, so that what does it mean? That if our water will be with more dissolved solids, our vegetation will have higher abundance, and if it has less dissolved solids, our vegetation will be lower. But if you see, this range is really ultra fresh water. I mean, it's in the range of mineral water. So it will be really interesting to consider this with a range. I mean, this data set was not able to do that, but maybe there are another data sets where we have like 700 microsiemens per centimeter, so that will be really really interesting to see how this went. And then, which is the impact of dissolved oxygen on vegetation abundance? Okay, this is really interesting because as long as we have more dissolved oxygen, we will have less precipitation. This is something that some biologists could argue, or maybe not. But let's see that we are just taking 14 stations, so I don't know. I mean, this is really surprised me, but I think let's say is I mean we have to develop some theory of what is going on and why we have less vegetation with higher dissolved oxygen, and then we have this is this is was it, and this is sorry nitrates. Okay, so on nitrates, if we have more nitrates, we will have more abundance of all vegetation. Okay, so as you can see, this is a feasible use of neural network for assessing the impact of water quality on ecosystems, and this is done in Python. This is a human code. Okay, so and then there are some key aspects that I can give you. There are some actions to consider in the effectiveness of neural networks. Some of there are consistent data, extensive data rate, consistent data, because if your data is wrong and then if you have some uh, bad procedures to take the data, you have non-calibrated, uh, you don't calibrate, or maybe your laboratory is not good, something like that. The computer could not understand what you are giving to the data because your data is wrong. Okay, you will need extensive data records because, and on my perspective, just 14 points to have to assess this will be like a small data set. Even if you do some statistical analysis, I will suggest, and I'm really that maybe you have 150 points, something like that. I mean, as greater, the greater. So if you have many thousands of data, the computer will have a better idea what is going on. Okay, understanding the governing rules of the phenomenon, this applies for everything. So the computer will understand, but will give you data that it has to, that you will need a criteria to see if the data is right, or like if you made some mistakes on the code, some mistakes on the data, or like because the computer can give you everything, so you have to understand what you are giving to the computer and what the computer gives to you. Okay, review the neural network theory, because there are so many parameters that we have done here and there are so many types of neural networks, so you have to understand which is the best neural network for the task that you will do. Okay, while considering these aspects, you can enjoy these awesome tools for your everyday work. And I will give you, for any example application of neural networks on a specific field, please write to okay, if you want to okay, sorry. Okay, if you want, sorry. if you want to do, I mean, if you have the idea about to set a specific example of neural networks, like please write to me. I will be happy to to assess you. I will be happy to see, I mean, if it is possible, maybe to do an example or tutorial of this, no? Because like machine learning is very interesting and there is a lot of things to do. Okay, please follow us by Facebook Hatariwater, Twitter Hatariwater. Please follow this YouTube channel. We will be posting very interesting stuff on water resources and as well on machine learning. Okay, so I hope that I can see you in another tutorials, and I hope that this will be very helpful for you. Once again, all the data of this code will be on the links below this video. Thank you.